So if you didn't figure it out, I didn't give you a lot of time, okay? But those ones that did figure it out in the short amount of time I got, good job. You're basically using logic to work backwards, okay? If I would have given you more time, guaranteed all of you would have figured it out. It's just we don't have a full class for you to get it figured out if you haven't already. All right, so again, do you guys agree that the beginning of the brackets every single time are the two things that multiply to give me the first term? Do you guys all make that connection? Do you guys notice that the end two numbers are always the two numbers that multiply to give me the last term? Okay, and do we have a little bit of calculations to get to the middle term? Right? The middle term always comes from, so just so you guys can see, this middle term right here always comes from the product of the inside and the outside, right? So that middle term always comes from, we multiply the inside two numbers, we multiply the outside two, and then those get put together by either adding or subtracting, depending on what sign we put on them. Okay? So there is two methods to factoring. I'm going to show you inspection. We're going to spend the day doing that. Okay? I find by time we're done class, inspection is the most efficient way to factor. There is another method, okay, that if you're like, I really don't like this, after a full day of trying, there is another method that I can show you that's not, I don't think, as efficient. Okay. All right, and to me, the way I'm showing you guys should be the most realistic of working backwards. Okay. The other one is just a process. All right, so something like this. Okay. All I would do is drop my two brackets. And again, just so you guys can see, is the beginning of my brackets always the two things that multiply to give me the first term. So what times what gives me m squared? M and m. Okay. Right? So I kind of ignore the middle term to begin with just for now. Okay. And I know the end of my bracket is always two numbers that multiply to give me the last constant. So the two things that multiply to give me 21 are, right, 7 and 3. What other two numbers would give me 21? Yeah, 21 and 1, but very rarely is it the higher product, okay? So 7 and 3, just give me 2 seconds. Okay, so 7 and 3. Now you have to, before you, I never do my signs at the beginning, okay? Now I check the inside multiplication. What is the inside multiplication? 7m. What's my outside multiplication? So I'm basically doing my area model just underneath, because are those the two terms I have to check to make sure that my inside number is good? So I do, like I said, I do my area model underneath because those are the two I have to check to make sure that middle term is good. So I need a plus 10. So you have to decide what are my signs. To get a plus 10, I need the 7 to be positive and I need the 3 to be positive. So we know that those both have to be positive. So if you check the inside first, that sign will go into the first bracket. If you check the outside second, whatever sign you put on there will go into your second bracket. Okay. Did you have a question? Okay. So it looks weird to begin with. Okay, but technically, am I undoing what we just did up here? Am I doing that? Am I just undoing what we did from the expansion? So again, instead of doing an area model, like I said, the only two that I have to check are the inside and outside multiplications because I know my two ends are perfect. Okay, so I just write it underneath instead of writing a square. Area model, if you want to do an area model to check everything, you can. Okay, it's a little bit more time consuming, but again, we have time. All right, so for this one, again, I know it's a degree 2 polynomial. You're only factoring degree 2 polynomials in grade 10. So 10C and 20-1, we only factor degree 2. 30-1, we'll start factoring degree 3, degree 4, and degree 5. Okay, But we need to conquer this because it shows up all throughout 20-1. You have to factor in many different chapters. Okay. All right. So here, drop my brackets. Whoopsie. And I promise you guys, at the beginning it seems strange, but I never have any students. By the time we're done day 1, it gets very comfortable. So it's okay if it's feeling a little weird right now. So again, what are the two things that are going to multiply to give me 2x squared? Exactly, 2x and x. And remember guys, if I ask you to factor a degree 2 polynomial, I'm not going to make these numbers huge because then factoring is not efficient. Okay. So what I mean by that, if I had like a 48x squared and 108 on the end, do you guys agree that you could be there forever? With huge numbers that have many, many, many factors? Yeah, that's not the purpose of factoring. The purpose of factoring, right, to be able to factor something is with efficient polynomials, numbers that you can use your times tables, okay, up to 12 to be able to break it down, okay. All right, so now, again, I'm ignoring the 7 right now. Do you guys agree I'm kind of ignoring the 7? I'm totally ignoring it for right now. So now I'm looking at the 15. So ignoring the signs for right now too, I'm just keeping it very simple for you guys. So what are factors of 15? Right, 5 and 3n, 1 and 15. But again, the amount of times you'll use the 1 with the constant factors is maybe 1 out of every 30 questions you do, right? And as you get good at this, you'll be able to look into the future a little bit more, okay? So I would try always the combination of numbers that are closest together. So do you guys agree that 5 and 3 are closer together than 1 and 15? So that's the one I would try. So this is where students are like, well, how do I know which one goes where? You don't to begin with, right? That's where the inspection comes in. So without any knowledge of anything, what do you want me to try in the first bracket, the 5 or the 3? Just pick one. Right? You want me to try the 3? So if you try the 3, that's why you use a pencil at the beginning, guys, because like I said, as you get better at this, you'll visualize putting the numbers in before you actually do it. Okay? But right now it's brand new. So you just put the numbers in, check. So the inside gives me a 3x. The outside gives me a 2 times 5 is 10x. Because we're doing that multiplication. Can I make a 3x and a 10x go together through addition or subtraction, right, to get me a plus 7? Right, the 10 has to be positive, and the 3 has to be negative, because plus 10x minus 3x, if you think of that expansion, so you're basically doing the expansion in a little space right here, right? So that inside and outside expansion, we're just doing it underneath, just so we can see it. So we definitely know that 2x times x is 2x squared, check. We definitely know that 3 times 5 is 15, but what kind of 15 do I need in the end? I need a negative 15, which will happen because, did I choose 2 different signs here? Yeah, so it's going to work. So the first sign goes into the, which bracket? The minus goes into the first bracket, and the positive goes into the second bracket. Should you technically get a factoring question wrong ever? Can you expand it to make sure you're right? Yeah, you can quickly do an expansion, right? You're literally putting it into its products, right? So if I have 2 products, you can expand it back, which technically that's what we're doing, okay, with our little numbers underneath. The only thing I have sometimes in grade 10, right, by 20, we're very efficient at this. Even at 10, we're very efficient. But the mistakes I see students do is they make their signs wrong. Do the signs actually matter? Yes, right? So if you put the positive on the 3 and the negative on the 10, that's technically not correct. Everything works except you're saying the quadratic at the beginning, right? The degree 2 polynomial at the beginning has a minus 7x, and it does not. So the signs matter. So that's the main thing students do wrong when they first start, is they do the integer stuff too quickly. So be careful, because you can check. Okay. So this one here are we okay with that one? And like I said, if you would have tried the 5 in the first bracket and the 3 in the second bracket, guess what? Those numbers would not have worked. So you would have had to flip them. Okay. Normally, the most trials students have to do is 3, but normally they get it on the first trial, okay, of putting the numbers in. Especially, guys, once you start getting used to this, can you visualize putting the numbers in and checking the numbers before you actually write them down? That's how, as you get more efficient, that's what you'll do. You won't just blindly put the numbers in. Right now, some of you might already be there, I don't know. Right now, I'm just blindly putting numbers in with you guys. Not blindly, there is obviously a process. Right, so it's a degree 2, drop my brackets. 2 things that'll multiply to give me a squared are a and a. Now, for 12, there's a couple more options. So for 12, I have 1 and 12. I have 2 and 6. I have 3 and 4. Do you guys agree that those are all my choices for 12? Can you guys already know which one's going to work? Because I need a 1 in the middle, because the coefficient on the front is a 1. So guess which will work? 3 and 4. Because if you put a 2 and 6, the inside's going to give me a 2. The outside's going to give me a 6. There's no way I can get a 1. Okay? So you can kind of see before you start. It's not just blindly not thinking at all with the numbers. So if I put a 3 and 4, and I don't care which one goes in which, because do you guys agree that both brackets have an A? Right? So unlike this one, it did matter where I put the numbers, because as soon as the first terms have another number other than a 1 on it, the second numbers matter how you put them in. Here, they're both A's. So if we're picking 4 and 3, then it doesn't matter which the 3 is, which one's the 4. But the signs do. So the inside, guys, I have a what? 3A. The outside, I have a 4A. I need a minus 1A. So which one needs to be negative, the 3 or the 4? The 4. So the 4 has to be negative. The 3 has to be positive. So again, if you check the inside always first, that sign goes into your first bracket. And the second sign goes into your second bracket. Is that starting to make sense? So, is it important that you know your multiplication tables? Is it helpful if you know your multiplication tables? Yes. If you don't, can you still do this? Yeah, you're just doing your factors on the side, right? So you can take your calculator and break down the number. Right. So this one looks weird, but is this still a degree 2 polynomial? This one's it's a special degree 2 polynomial. It has its own name. Okay? This is called a difference of squares. Okay? And we've expanded them before. Okay? So you factor these, all of them, guys. The nice way about inspection, you factor every single polynomial the same way, right? As soon as it's simplified, and all the ones we're doing today are simplified. That doesn't make sense yet, but everything is just a degree 2 polynomial that gets 2 brackets. Okay? So this one we still factor it the same way. Then these ones are actually, you're really happy when you get difference of squares, because what do you guys notice about those two numbers? They're perfect squares. So you're going to build 2 brackets that are almost identical. Okay? What are the 2 numbers that multiply to give me 4v squared? 2 and 2. Because they're perfect squares, guys. The numbers you're using are the numbers that you would get if you square rooted those numbers. That's what you're using. So you don't actually have to think about combinations. Square root of 4 is 2. So it's 2v and 2v. Square root of 25 is 5. So you're using 5 and 5. The inside gives me a 10v. The outside gives me a 10v. What do I need those to do? I need them to cancel each other out. They need to disappear. Those needed to be the same, right, for that to happen. Hence why in your difference of squares, right, you're going to do exactly the same brackets, except one will be negative and one will be. Doesn't matter which one I put where. Doesn't matter if I would have put the plus in the first bracket and the minus in the second bracket. No, that doesn't matter. Okay. So these ones, like I said, I put everything together. Some teachers teach them all separately. We factor them all the same. So to me, I'm not separating anything, right? Because on your quizzes and on your tests, they're all going to be put in a big group, and it's going to say factor. So just realize this one does have a special name. It's called a difference of squares. Not that it matters. Oh, that's really thick. I'll redo that. So this is called a difference. So difference of squares. Is that name appropriate for this? Is that name appropriate? Should, if you understand the vocab. What does difference in math means? Subtraction. Are we subtracting squares? Yeah, so that is why it's called a difference of squares. So in 10 and 11 and 12, okay, we factor difference of squares. There is something called a difference of cubes and a sum of cubes, but we don't factor them until calculus. Not that they're really hard, but they just don't apply to the curriculum until then. Okay. All right, so this little guy here, so drop our brackets. So this one, we have a little bit of choice. So what are the two numbers that you want to multiply to get me 6x squared? 3 and 2. Perfect. Now, is there a chance it could actually be 6 and 1? It could, but I'm going to try the smaller. The only time I try the larger is if the middle term's a really big number, like a way bigger number. Does it make sense that I might have to go with the 6? That's how I decide. Because at the beginning, I don't know which one it is. Just like you guys. I don't know if it's 6 or 1 or 3 or 2 to begin with, but I look for kind of signs to help me figure it out. So, and again, it might end up being 6 and 2. We're going to find out very quickly. Okay. All right. So the nice thing though, for 5, I only have one choice. I have to use a 5 and a 1. So what do you guys want me to try in the first bracket? 5. Okay. So if I put 5 in the first bracket, and 1 into this. You guys are getting good at this. Did you already get it bang on? Are you guys visualizing that? What's in the middle right now? What did you guys create in the middle? 10. What did you create on the outside? A 3. Right? So a 10x in the middle, a 3x on the outside. Did you guys get it perfect? Yes. Okay. Because again, the inside is a 10. So as I was saying, if you start kind of looking at that in your mind before you write them down, you'll always get it on your first try. Right, so again, the inside gives me a 10. The outside multiplication gives me the 3, right? They both have x's on them. I need a plus 13, so they both have to be positive. And please make sure, guys, that you double check that the multiplication of your end is okay as well. Right, so I know that 5 times 1 does give me the 5, but what's more important is positive 5 times positive 1 gives me a positive 5. Because if one of those were negative, would you be now wrong? Yes, right? So just make sure that always the two signs that you end up putting in the end work with the last number through the multiplication. Is that starting to make a little bit more sense, guys? All right? So, and you're probably thinking, this is the most important skill that we're learning? It is, like it is, believe it or not. And it's not a hard skill, it just takes some practice. Like I said, main is signs, right? Signs, you have to be careful with signs. All right, so this one. And right now, guys, I'm giving you all degree 2 polynomials that have no greatest common factor, which we're going to learn about tomorrow, because you might have an extra step to do, which, like I said, I'm going to show you tomorrow. But it's a fast, quick step. All right, so with this one, What are we starting with? What two things multiply to give me x squared? X and x. Okay. Now for 24, right? We know it's 1 and 24, 2 and 12, 3 and 8, or 4 and 6. So if you visualize that, do you know which one you have to use? Yeah, because you need a 5. And since the coefficient on the first one is a 1, that's why we can look at that and go, oh, 3 and 8 can give me 5. That only works when this leading coefficient is a 1. Otherwise, you have to do, like, there's a little bit more math involved. All right? So we can just, and right now, does it matter which one I put the 8 as? No. Signs matter, but like I said, I don't do signs till the end at a grade 10 level. Even actually at the grade 11 level either, I always put my signs at the end. Right? Because I just want to make sure I do my signs properly. So, inside gives me an 8x. Outside gives me a 3x. I need the 5 to be negative, or I need the inside term to be negative. So the 8 has to be negative, and the 3 has to be positive. Right, that's it. So then, if you check the inside first, that sign always goes to your first bracket. If you check the outside second, that sign, whatever's on that term, goes into your second bracket. And again, it doesn't matter if you have those brackets flipped, because you guys agree multiplication, order doesn't matter. 3 times 4 is the same as 4 times 3. So therefore, x minus 8 times x plus 3 is the same as x plus 3 times x minus 8. So the order of the brackets doesn't matter. The signs do matter, though. Okay. All right, I'm going to do 3 more with you, and then I'm going to let you guys, I'm going to do 11, because that's a special one as well. 10, just those two. And then I'll let you guys do those last 4. I'll still do them, but I'll just do them quietly behind you. And then I guess there's a lot of them. There's 9 more, so I'm going to do 2 more with you guys, and then I'll just go silent and do them as well. But you guys can do them without me talking. All right, so for this one, okay, so drop our brackets. All right, so what do you guys want to try for 6? Do you want to try 6 and 1 or 3 and 2? 3 and 2. Okay. And then for 10, do you want to try 10 and 1 or 5 and 2? Okay, so if you want to try 10, right? But again, that's okay. Like but this is what you should be thinking before you use your, like, write stuff down. If you put a 10 in here, what are you creating? A 30. If you put a 10 in here, you're creating a 20. Okay? And then 20 and a 3. So again, that's what you would do. You'd put it in, you'd see that it did not work. So you just use your eraser and erase it. So to me, I look at that and I visualize if I put a 5 in here, I'm creating if I put a 5 in the second bracket, I'm creating a 15. And then if I put a 2 here, I'm creating a 4. Does 15 and 4 give you 19? Yeah, so if you kind of visualize it before you write the numbers, it's just going to save some erasing, right? Because you technically can put them in with your eyes and do the quick inside-outside. And you guys will also learn more tomorrow that you can't actually ever put a number in the bracket that is common, right? Because that creates a GCF, which we'll talk more about tomorrow. So that's just going to save you some trials. But like I said, that's confusing right now because we haven't talked about GCF. But I will add that little trick tomorrow. So I'm going to do 5 and 2. Okay. So then now you guys can see what we already talked about. The inside gives me a 4m. The outside gives me a 15m. They both need to be, because I need a minus 19. What does it need to be? Both. Because remember when you're doing integers, guys, minus 4m minus 15m gives me a minus 19. Just think it's 4 degrees outside below 0, and it's getting 15 degrees colder, right? Right? They're not side by side. They don't turn to a positive. You're not multiplying them. So minus 4 minus 15 is minus 19. They both need to be negative. And did that work for the 10? Because a negative times a negative is a positive. Okay. Okay, last one, and then I'll go silent and let you guys do the last ones in the notes, and then you can practice the one from the assignment booklet. I know it's a lot, guys, but to me, if you do all the practice, you're going to be like factoring kings and queens or whatever you want to call it. You're going to be amazing at it. Okay, but it does take practice. So with this one, not that you would for sure see it, okay, but you just with this one, there is. What do you guys notice about the first and last number? They are a perfect square. Okay, this one here is called a perfect square trinomial. Those are your kind of two special cases, right? Your difference of squares. Not that technically, guys, do you even need to notice that they're a special case? No, you don't. Do you factor them the same way? You factor them the same way. It's just you'll notice that these special cases, difference of squares, the brackets are almost identical, except one's negative, one is positive. You're going to find when we factor this, let's watch what happens. Two things that'll multiply to give me 4a squared are 2a. So 2a and 2a. Two things that'll multiply to give me 49 are 7 and 7. 14a, 14a. I need a minus 28, so they both need to be negative. Right? So if you notice that it's a perfect square trinomial, that means both brackets, when you're done, should be exactly the same. So you can write it like that. Some students prefer to write it like this. Only you can't do this with difference of squares, but you can do it with perfect square trinomials. Is that the same thing? Yeah, and you don't have to write it like that, right? But you can. Those two things mean the same thing. The only time you can do that is if you're factoring a difference of squares. So if you notice that it's a difference of squares, again, the middle one's not perfect, but the outside two are. Okay? And obviously it has to make the connection. The inside and the outside have to give you the middle term. So I'm going to put the word here, even though it's in your notes later. This one is called a perfect, exactly perfect square trinomial. I like to hear that. Like I said, factoring is usually not a big issue. It just takes practice to make sure you guys get your signs correct, right? That's the biggest mistake I have when students are first learning, that your signs go into your binomials correctly. All right, so I'm going to go cone of silence now, but I will start at 7 and just factor them so you can look up when you're done. Even though technically, guys, do you need me to check your answer? No, you should be doing your like your quick little expansion, but it's just nice to be able to look up and go, yeah, okay, I'm going to move on. Okay, so please finish the last 7 of them and then go to your assignment booklet, and I know there's probably another 20 of them or 25 of them there. Promise if you can get through all those today, tomorrow when I add an extra piece to the puzzle, that will just go more smooth if you're not caught up on this part of it. Okay. And as you get good at it, guys, like Do you have to show this work underneath? No. If you can see it, right, without putting that work underneath, you don't need to, okay? Usually in grade 10, this is very helpful. So I encourage you to do it. More students that do that underneath make less errors on their signs, okay? But by the time we hit second semester when we're factoring, normally this kind of goes away because more of it's just done in the head, okay? But if you feel like you get there before second semester, again, if you're doing it well, again, I don't need to see the bottom pieces. That's just more to confirm everything that all the sign stuff. Oh, I didn't even see this one. Another different, or perfect square trinomial.